all those problems on trigonometry. Okay, so I gave you 2 up to 10, wasn't that right? 2 up to 10? 2, oh my God, I gave you an awful lot of work, didn't I? Right, okay, so number 2, anyone? Did you check your answers? Number 2, anyone? 3, anyone? 4? 4, right, okay, so we have, I'm leaving out the pictures of the boat. Oh, wait now, up, he might be able to see what I'm doing. Right, so there's a boat and there's a point, right, and there's another boat. So there's a boat at Q, there's a boat at P, there's a right angle, which is what we want, right, and there's a point R, right, and it tells me this one is 112 and this one is 54, and part 1 asks me to find the distance from Q to R. So the distance from Q to R is, I'll put an X on that. That's what I'm looking for. Okay, that's the first section of the chapter Pythagoras' theorem, when you know 2 sides and you want to find the third. Okay, so all you need to do is label the hypotenuse for this. You can't label any further because you don't know what angle you're talking about. So the only one you need to label for this is the hypotenuse. So remember, h squared is equal to a squared plus b squared. So that means x squared is equal to 112 squared plus 54 squared. Remember, it doesn't matter which one you call A and which one you call B, right? Okay, into the calculator that, and you get x squared is equal to, I did this yesterday, I've a answer, x squared equals, say that again? 460, and then you get the square root of that, and you round it up to 1 place of decimals, to the nearest whole number. You round it up to the nearest whole number, and when you round that up to the nearest whole number, your answer is 124, girls. Okay, is that okay? So that's 124. And put a unit on it. They told me everything was in kilometers, so obviously that's in kilometers. Okay, then for part 2, they asked me to find the angle PRQ. So PRQ. So it's always at the middle, so it's at R, so it's P to R to Q, so it's in here, right? So I might put a capital X on that. Is that okay? So then, now I can label, the hypotenuse is still the hypotenuse, but now I can label opposite and adjacent because I'm actually talking about an angle. So the 112 is beside the angle, the 54 is opposite it. So you do SOHCAHTOA. So I'm looking for the angle. Okay, so I'm looking for sine, cos, or tan. And I know the opposite, and I know the hypotenuse, and I know the adjacent, and I know the hypotenuse, and I know the opposite, and I know the adjacent. Right? Okay. This one's unusual in that I have everything has 2 ticks and a question mark. Agreed? So which one do you use? Any one. You're going to get the same answer. So it doesn't matter which one you use, you get the same answer. So will I use sine because it's first? So it's sine of the angle x is equal to over h. So I'll just come over here. So that means sine of the angle x is O is 54, h is 124. Then when I'm missing the angle, I type in shift and sine. So that's what you do when you're missing the angle. 54 over 124 and equals, and you get that the angle x is equal to, again rounded to the nearest whole number, well, 26 degrees. Okay, are we good? Right, that's number 4. Number 5. Anyone? Number 6. Number 6. Right, okay, so number 6. right, has this sort of a shape, so it goes all the way over there, right? Okay, the whole length here is 50 meters. The length here is 14 meters, right? This is 2.5 meters, and what they've done is they have made an extra angle here and they've called it theta. That's just a Greek letter, it's like A, B, C, whatever, okay, so don't worry about that. Okay, right, so that angle is not in a right angle triangle, right? But I can make it into a right angle triangle, can't I? If I just connect up there, would you agree? Now it's in a right angle triangle, agreed? So I'm just going to draw that right angle triangle out here. Now, if that side is 2.5, this side is also 2.5, isn't it? Okay, now I need this side. So the whole length is 50. This length is 14. So what's this? So if the whole lot is 50, this is 14. How do I get this? You? Anyone? Take it away, don't you? So it's 50. So this would be 50, take away 14, which would be 36, yeah? Okay, so that's 36 meters there. Right, okay, is that okay? So now we have my right angle triangle. This is the hypotenuse, this is the adjacent, this is the opposite. So we write SOHCAHTOA. So I'm looking for the angle, so that means I'm looking for sine, cos, or tan. Right, I know O and I know A. O and A, O and A. Right, so this one I don't have a choice. I have to use what? Tan, because it's got two ticks and a question mark. Okay, so it's tan of the angle, which is theta, equals O over A. So that means tan of theta equals O measures 2.5, A measures 36. In your calculator, write shift and tan, shift. When you're missing the angle, which I am here, you go shift tan 2.5 over 36. And they said round it up to the nearest whole number, and your answer is, say again? 4? Right, that's a very small angle, but yes, that's what it is. Is that okay? Are we good? Right, okay. That's number 6. Can I take it away? Right. Anyone for number 7? I think I did number 7 yesterday. Right, number 8. Am I doing 8? 8. Right, okay. So Andy stood, so here's Andy. Right? Okay, now I don't know if it's relevant, but we do know Andy is a person standing up straight, so he makes a right angle with the ground. Okay? Then Andy's eye is here. Right, that's a rectangle. Right, okay, and then we have a tree here. So remember, a tree also makes a right angle with the ground, doesn't it? Okay, right. So that's a rectangle there. Okay, so here I have this. That's 20. Then he went to the top of the tree. So that would be 59. And this down here at the bottom is 5 meters. Okay, are we all good? Right, now if that's a right angle, this is the tree is up straight, so that's also a right angle. Is that okay? Are we all good with that? So that means that one is also a right angle. So I've mapped in a good few right angles there that they had mapped in. Right, what is the length from G to H? So G to H is this line here. It's a rectangle, so what would that line there be? G to H, so this is G to H. I've just made a rectangle, right? So this is 5. This one here is also 5, right? So G to H is 5. So GH is 5 meters. Work work out the length of T to H. So T to H is here, T to H is this line here, see it? Okay, so it's not all the way to the ground, right? Okay, so T to H, so that's 5, that's 59, and I'll stick an X in there, right? There's my right angle triangle. Is that okay? So label, this is the hypotenuse, this is the adjacent, this is the opposite. So SOHCAHTOA so I know the angle is 59, so that means I can get sine, cos and tan of 59. I'm looking for the opposite, so question mark on the opposite, and I know the adjacent is 5. So which one am I using? 10 again, right? Okay, so it's 10 of the angle, so it's 10 of 59 equals over A. So 10 of 59 equals X over 5. So when the X is on top, what do you do? Cross multiply. So put that over 1. 1 by X is X. And 5 by 10 of 59 into the calculator. Press equals. And we get, it says, 1 decimal place. What's it? 8.3. Okay, meters. Okay, so that's 8.3 up there. Are we good with that? Okay, now the next one is what other calculations needed to be found to find the height of the tree. So the whole tree is T down to the ground. Okay, I have T down to H, so I have to find the H down to the ground, don't I? Would you agree? Which is also the height your man standing over here, whoever he is, right? Endy. It's also the height of Endy, isn't it? Okay, I don't know, is that relevant? But just so we know. Right, okay. What is the height of the tree? So I need to get this line here. See that? So I'm going to call that X. That's also in a right angle triangle. Okay, the right angle triangle is like this. That's a right angle triangle. This is X. This is, what's it, 20, is it? And this is 5, agreed? Okay, so it's an upside down right angle, but you just have to look for the right angle triangle where you have 3 pieces of information. This is hypotenuse, this is adjacent, this is opposite. Agreed? So I go SOHCAHTOA. I know the angle, so that means I know sine, cos and tan. I'm looking for the opposite, so question mark on the opposite. And I know the adjacent is 5, so I'm ticking the A's. I'm using 10 again, aren't I? Okay, so it's 10 of the angle 20 equals over A. Right, so that means 10 of 20 equals X over 5. When the X is on top, what do? Multiply. So put that over 1. 1 by X is X. And over this way go 5 multiplied by 10 of 20 into the calculator and round it up to 1 place of decimals. Someone shout louder. 1.8. Right, thank you. 1.8 meters. Now just be careful, girls, that's not what they asked. They asked for the height of the tree. So the height of the tree is the 8.3 that you've already calculated, add the 1.8, isn't it? So it's 8.3, add 1.8, which would be 10.1 meters. Are we good with that? Right, okay. So again, looked pretty complicated, but you just have to break it down to right angle triangles. And remember, you can only work in a triangle if you have 3 pieces of information. Okay? Number 9? Am I doing number 9? Right, okay. Can I take this away? Right, number 9. At the edge of a beach, which is 8 meters wide right? There is a 21 meter high wall, so there's a wall here and it's 21 meters, right? Okay. Okay, so over the water isn't, right, so the water is here, but it's not in the right angle triangle, so from here to here is 8. Isn't that right? Okay, then they've drawn a triangle like that, and they've also told me that this one up here is 6. Right, okay. The angle of depression, so that means if you're on top of the wall looking down. So an angle of depression is if you're on top of the wall looking down, right? How far is it out to sea for the swimmer? So look, I want the length of this line here. Okay? And then if I take away the 8, I'll know how many meters out in the sea he is, won't I? Right? So if I get the length of the whole line, right, okay, I'll give your answers in nearest meter. Right, okay. Right, the first thing is, this is a wall. So the wall makes a right angle with the bottom, doesn't it? But it also makes a right angle with that line up there. Okay? So if that bit, so the whole angle is 90 degrees. So if the bit there is 6, what's in here? 84, isn't it? Do you all see where I came up with that 84? So it's a right angle because it's a straight up wall, so that means it makes a right angle with a straight line across. So if this bit is 6, the other side is 84. So I'm going to draw on my right angle triangle there. Okay, this is 21, this is a right angle, this is 84, and I want to know the length of this whole long line there. So the whole long line is what I'm looking for, so will I call that X? Is that okay? Label. Hypotenuse, adjacent, opposite. So SOHCAHTOA that's not us, is it? No, I always get mixed up with that. Sine, cos and tan, I know the angle, it's 84, right? I know the adjacent, it's 21, and I'm looking for the opposite, so I'm looking for O. So it's 10 again. Right, this is just happening that it's always 10. Okay, it isn't always 10. Right, so we go tan of the angle, which is 84, equals O over A. So that means tan of 84 is equal to X over 21. X is on top, so cross multiply. 1 by X is X, and in your calculator multiply 21 by tan 84. Okay, and the answer would be rounded up to the nearest whole number.
Miss, isn't it 2.1?
Sorry?
Isn't it 2.1?
Is it 2.1? Sorry, it's not 21, it's 2.1. Apologies. What? Is it? Oh, it is. God almighty, that's an awful, that's a few. I wasn't really thinking right, because 21 meters is a fierce high wall. Right, okay? So it's 2.1 multiplied by 1084 into the calculator, so please, and press equals. Round it up to the nearest whole number.
20.
What's it?
20.
20? Sorry? 20? Right, okay. No, but look, I'm not finished. So from the bottom of the wall all the way out to the swimmer is 20, but they only want from the edge of the water out to the swimmer. Right? So if the whole line is 20 and over to the edge of the water is 8, that means from the edge of the water out to the swimmer is 20, take away 8, which is 12 meters. Is that okay? Okay. Right. 10. Am I doing it? Yeah? Yeah. Okay. I did half it yesterday, did I? So which bit do I need to do? Who's asking me to do 10 first off? Right, which bit, Safia?
The first part.
Did I do the first part yesterday? I did all of 10 yesterday, so if you look up the video of yesterday's class, you'll see number 10. Right, okay, right. Number 11, anyone? No. 12. 12. Right, okay. So number 12. A flagpole is on top of the building. So there's a building, right? Okay. And then there's an extra bit on top, which is a flag. Again, right, it's all straight up, right? Flagpole straight up, right? Okay. So then we have from a point D, 4 meters from the bottom, there we have 4 meters. The angle of elevation to the top A and the bottom of the flagpole, right? Okay, so we have, so we have to the bottom of the flagpole and to the top of the flagpole, right? Okay, that's a right angle, it's a building, right? I have 2 right angle triangles in there. So the smaller angle is 68 and then the bigger angle is 74, right? Find the length of AC, so that's the whole length of the line, the big line there, right? Find the length of BC, right? Okay, so BC, so then I'm going to get that line, and then I'm going to subtract them to find the length of the flagpole. Okay, so I actually have 2 triangles here. I have a bigger one, and I have the smaller one, don't I? Does everyone see that? There's 2 right angle triangles in there. I can't work with this one at all. But you see this little, small little one there? Why can't I work with that? Because there's no what? There's no right angle. See that little triangle there? There's no, see this little triangle here? I cannot work with that because there's no right angle in that. I can only work with right angle triangles. So this is 4, and in the big triangle it's also 4 because it's from the same point. In the little triangle it's 68, and in the big triangle it's 74, isn't that right? This is where the building hits the ground, so it's 90 degrees. Okay, so I need to find this line, I call it X, and then I need to find this line, and then if I subtract them, so I'll have all the way to the top and just all the way to the top of the building, and if I subtract, I'll get the length of the flagpole. Is that alright? Okay, so in the small triangle, label HOA. Would it be okay if I didn't write socket O and didn't do the ticks? Because I think you get that, do you? Yeah. Right, okay. So when you fill it in, you're looking for ops and adjacent, you'll be using 10 again. So is it okay with everyone that I skip to just you're using 10? Right, because when you do the ticks and the question marks, that's the one you'll need. Right, so you get 10 of 68 equals O, which is X, over the adjacent, which is 4. X is on top, cross multiply, 1 by X is X, and you do 4 by 10, 68, and someone might multiply that for me and round it up when out we see 1 decimal place, they tell me. Say that again. 9.9, right, 9.9 meters, okay? So that's that bit, that's in the smaller triangle. Now, in the bigger triangle, OA hypotenuse, you're going to end up using 10 again, but this time it's 10 of 74. So 10 of 74 equals opposite, which is y over 4. Cross multiply, 1 by y is y, and you get 4 by 10 74. Into the calculator, press equals, right, and round it up to 1 place of decimals again, and you get, say, good and loud.
13.1.
Thank you, 13.1. For the old deaf people in the room, you have to be considerate of them. Right, are we okay? Now, so all the way to the top of the flag is 13.1, and to the bottom of the flag is 9.9. How do I find out what the flag is? Subtract. So you do 13.1, take away 9.9, take away 9.9, and that will give me 3.2 meters. Are we good? Right. 13? 13? Am I doing it? I don't like the look of 13 anyway, just don't mind it. 14, 15, 15, yeah. 15, are people saying yes to 15? 16, right, 16. Right, shows a vertical cliff face, PZ. Right, okay, so we have, again, lovely story, cut to the chase. Where are my right angle triangles? So this is 7 meters. This is 44 meters. The whole line here is 18 meters. So I have 2 right angle triangles here, right? So I have the bigger one and I have the smaller one. Agreed? They both have a right angle in them because that's where a cliff or something hits the ground. Okay? Is that right? So this is 44 degrees. I put in meters. That's not meters, that's degrees. Okay? In the big triangle, that's 18. And this is 7 meters. Okay, and that's all I have in that triangle for the moment. Right? So I have to work out the height of the cliff. So part 1 asked me to find out the height of the cliff. Okay, it's in both triangles, but I'm going to work on which triangle, big or small? Big. Why? Because that's where 3 pieces of information, isn't it? Over here I've only 2 pieces of information. I've only 7 in the right angle, so I've no choice but to work in this one. So you label and then you do your ticks. Am I okay with going straight to, you pick 10? So sorry, I forgot to do my labels. Higher, hypotenuse, adjacent, opposite, yeah? So you're going, then you do your ticks, and then it's 10 you're going to pick. So 10 of 44 equals over A. So 10 of 44 equals x over 18. Cross multiply, 1 by x is x, and the other way 18 multiplied by 1044, and it says, doesn't say correct how many places of decimals, so we'll go with 1 place of decimal, right? What's it? 17.4. So that there is 17.4. But remember, that's also in the smaller triangle, isn't it? Okay, it's the cliff face which is in both triangles. Agreed? So look, now I have 3 pieces of information in the smaller triangle. Let's see what they want me to find out. Right? Work out the angle of elevation of P, right? So of P from the point Y on the beach. So this is the point Y, this is P. The angle of elevation is on the ground looking up. I'm looking for that angle there. Will I call it capital A? So I'm looking for a capital A. Is that okay? Right, so label, hypotenuse, opposite, adjacent. Okay? So again, you do your ticks and whatever, and you'll end up using 10 again. So it's 10 of A, this time I'm missing the angle, equals O is 17.4, adjacent is 7. So when I'm missing the angle, I have to do shift and 10 and 17.4 over 7, and they said round it up to the nearest whole number. 68? 68 degrees. So that means that angle there is 68 degrees. Okay? Work out the size of the angle XPY to the nearest degree. So X to P to Y. X to P to Y is the angle in the big triangle, isn't it? Now we don't have to do any X to P to Y. Sorry, it's not. X to P to Y is this angle here, right? Okay, so what we need to do is we just need to do the 3 angles in a triangle add to 180, don't they? Right, okay. So this is 90 and 44 is 134. 180 take away 134 is 46. Is that okay with everyone where I came up at 46? Right, 3 angles in a triangle add to 180. Right here, this is 90. I worked that out to be 68. So 90 adds 68 is 158. 158 from 180 is 22. Agreed? Are we okay? So the whole big angle, right, is 46. And from here to here is 22. So how do I find out that bit? So the whole big angle is 46. The little bit here is 22. So how do I find out the missing bit? Subtract, isn't it? So it's 46. Take away 22. And that'll give me 24 degrees. Okay, and that's it. Right? So that was number 16. Okay, girls. Right. That's the end of the chapter. Okay, and I think that's as hard as the questions get. Okay, right, as in the last few we've done. Right, okay, is that so? That's where we're at. You look for the right angle triangle always, because you can only work on a right angle triangle. And remember, you need 3 pieces of information. So if they don't give you 3 pieces of information, they give you a way to find an extra piece of information. Okay, so like the last chapter, girls, I don't want to waste time on a test